this, you can, or or oh, no, wait, Stefan. He has got the control. Yes, okay.
You speak loud if I'm late, just say Matthew.
Yeah, sure. No, that's not the problem. You have to need to know that because there are some slight changes there, so we have to figure out if we change it, you change it. Okay, we'll take our decision. Or you want to sit here? You want to start on the stage? It's fine, thanks. Okay, welcome. Please take your seats. So good morning. This is the quantum sensing session. We'll follow same type of procedure that we did just previously. My name is Stefan Kröll. I'm from Lund University in the south of Sweden. My background is working with rare earth iron doped crystals for quantum computing and quantum memory work. So actually, I'm not very knowledgeable in quantum sensing. Why am I standing here? Well, there is a 100 million euro Swedish program on quantum technology from the industry and from private foundations and the state. And I'm coordinating a quantum sensing part. So this is a learning experience for me. But there are some people here that know something about quantum sensing. So there are two more, please.
So my name is Ivo De Giovanni from the INRIM, that is the Italian National Metrology Institution. My background is essentially quantum photonics, but I've got also some interest in quantum clocks. And essentially I'm also the person who is trying to build up with the collaboration of all the other, the European metrology networks on quantum technologies under Euromet.
And in the back, taking notes.
No? Yes? Okay, I'm Matthew Munch. I'm from a startup. I co-founded a startup. I'm going to be your note taker, and you can see that we're in kind of a working mode. There is no slideshow today. I'm going to try and summarize the main points that you raise live here. And it would be absolutely fantastic if you can come in the end and tell me your name, if your comments appear here, so that I can follow up with you. Thanks.
Okay, so we'll take the first slide. And you can see that we'll follow the same procedure as we done in the previous sessions. So what should be included in the flagship and in the strategic research agenda, and then the goals, and then enabling technologies and so on. So we'll follow the same scheme. I don't think that we need to repeat that, so I guess we'll take the next slide directly. So, so the things in the red, items in the red are funded in the first round: atomic clocks, miniature atomic vapor cells, spin quantum sensors, ENVI centers. There may be some other things that also are funded. The other things that are listed here are the things in the European quantum technology roadmap. So what is mentioned in that? And I think there are two things we might think about. I mean, what would be really important to get into the flagship? What is really important to stress in the scientific research agenda, which is the basis, or at least one of the input for the next flagship call. So I guess at this time we want to have input. Really, what really should go in? What is missing? Or possibly, I mean, the black thing is taken from the quantum technology roadmap. So, is there anything that's obsolete now also? So I guess at this time we'll ask for comments. So Eve is deciding here who is speaking. So when you wave your hand, you can check Ivo when he is pointing the way that.
Yes, Stefan Kück, Physikalisch-Technische Bundesanstalt, Germany. I have two comments to that. The first one is should be a match and to look what was originally in the roadmap and the strategic research agenda, what is missing already from that, due to what is not in the funded project right now. Then there's another point, what is sort of missing is there something like standardization certification needed, and how do we address that? It was also a discussion point in the last session on communication, so that's there's essentially no real project dealing focused on this, and so maybe how is this going into the whole thing?
Okay, so I will generally always try to summarize what people have said, so Mathieu sort of acknowledged that he got that. So as I understand, your point was we need standardization and certification, and that has to be in the project. Is this correctly understood? And it should match the...
So what is already now missing compared to our already existing roadmap and strategic research agenda? Because not all were addressed. I mean, we just check it. Because we have already a lot of things which we should do, and it's probably not addressed right now.
Yeah, so again, I'm trying to get the point, because you're saying there is a lot of quantum technology issues which are important, not in the flagship like now. Both the one in the flagship and outside needs standardization and certification. Is this correctly understood?
Maybe you can help.
Yeah. Well, flagship is basically targeting the application of quantum technology in industry for stakeholders, and for this standardization is inevitable, necessary. Certification, so somehow to, you know, it's not only research, is it? I still don't understand. Okay.
Okay, so again, I'm saying the same thing as Ivo, that please, those that have stated something, talk to Mathieu afterwards, give name, which also means that you can recheck that it's really what you...
Yeah.
Paolo Bianco, Airbus. I think that's something that we're probably missing, so mine is a reply rather than an answer, is a bit of a swipe from the defense perspective on the sensors. I'm surprised to see there's no quantum imaging that has made it through, and optomechanical sensors, if I'm right in my understanding, basically you mean accelerometers, gyroscopes, and so on. And these ones are missing. I'm not sure if it has to be through the quantum flagship or it has to be through any European entity, but those are strategic for the defense industry in Europe.
Yeah. Okay. So summarizing, missing, we have quantum imaging, we have optomechanical sensor, which is a really large area. And it's, I mean, your point is also, you look from a defense industry perspective, these are the things that you feel are. Yes. And at any time, if you think I'm unclear or so, just tell me.
Yeah, hello.
Yep.
My name is Andreas Janet. I'm working for the Joint Research Center. We have a joint initiative together with standardizers such as CEN and CENELEC, which are the main, beside ETSI, in the European context. And this joint initiative is to bring science closer to standardizers, and we offer especially for the quantum flagship, we offer a workshop, a conference in the end of March, 28 and 29 of March next year, where we would like to highlight specific cases where standards have been already developed or are in the verge of being developed in order to give a guideline to scientists who are in the community of the quantum flagship. So I would like to invite all of you who are interested to come to this workshop. We are still in the phase of defining the agenda. So I would like also to invite especially the people from the support action to design together with us this workshop, and it will then help to bridge to bring the results from the findings of the quantum technology flagship more to accelerated market access.
Okay, so maybe a little bit outside exactly what we're asking for, but your point is that the company you're representing want to discuss how to do standardization, which we think is an important part. There is a workshop at the end of March, and I guess you have made the message through.
Okay. Thank you. I'm Eugene Pollack from University of Copenhagen. And I would like to thank the organizers. If anything else, this is a great place to meet old friends. But I have a specific statement, which is the following. There are large-scale European projects, CERN, or, for example, the upcoming Einstein telescope for gravitational wave observation. And, speaking from my own platform, I think we can offer something which will push the quantum boundaries, for example, of the gravitational wave interferometry, like the upcoming Einstein telescope. And I believe that if we kind of issue some kind of a call or initiative to the members of the flagship with the list of a number of large-scale European projects, and again, to me, maybe only this Einstein telescope and Virgo from the gravitational wave and CERN comes to mind, but I'm sure people can think of many other things. How quantum flagship can actually help those other European large-scale initiatives, and it might not even be a large lump of money, but it will certainly raise our visibility. Okay?
So, I mean, I'm adding a little. I mean, the point is there are really important things in quantum technology, not in the flagship now. Question is, how can one get it in? One thing is collaborating or at the flagship, another way, establish good contact with large European scale projects, and that's really a path into exploring quantum or offering them quantum or enabling that with them. Rainer Erdmann from PicoQuant Berlin. I would expand the comment we heard about quantum imaging, and I would not even focus that only to defense, but there is a nice overlap, which seems to be not so much visible in the community, that there could be a lot of beneficial cooperation between the life science community doing a lot of quantum-based imaging, having single emitters, which are by definition quantum states. And we had a fantastic event just in spring where you attended, where we heard from the US. They already cover both the life science as well as the security and communication-based field. And I would say there could be a lot of beneficial cooperation if in the flagship these topics get also a little bit more attention. Okay, let's see if I got this right. So it's about quantum imaging, and it's not only defense application, it's life science. We also have, in general, the single photon detectors, which is a source here that is useful. And that should be emphasized at some point. Is this correctly understood from what you said? Very similar technology, very similar algorithm, and so there's a lot of experience, and looking to a topic from different direction always helps. And networking with these experts would be definitely strengthen the flagship. Yeah, and I mean the other thing is that additionally to what I said before, you put some emphasis on the recursive algorithm. Was this correctly understood? Yeah, okay, thanks. Okay. This one.
Wolfgang Ernst, Graz University of Technology. What I'm missing is quantum plasmonics for single molecule detection. We are making nano-sized core shell particles with special design for special absorption and enhancing electric field for single molecule detection, and I haven't really seen this area represented.
Okay, so this is about the quantum plasmonic field, and it's about the quantum imaging of single objects. I guess there are the ENVI centers, but there are many other single quantum systems that are important in various areas.
Philippe Chomaz, CEA. I would like to comment on the question about the connection with large-scale facilities. In fact, in QFlag, the next CSA, we have proposed to strengthen this part to connect with CERN, ESO, ESA, and there will be different actions. And in fact, action is already starting because we are not waiting the next CSA to start because this will be in 2019, but why not starting now? And for example, next week there is an initiative by CERN and it's connected with the flagship. So there will be 2 days at CERN where they discuss the possible use of quantum technologies. And we bring them this input from this community on the computing, on the sensing. But we have also in Grenoble in December a first test within France. We call that ultimate sensors, and we bring biologists, we bring different type of chemistry people, physicists. We bring different also industries using high tech. And we believe that we need to strengthen this part to connect with high-tech communities, whatever in industry or in the academy, large-scale infrastructures, but not only, in order to provide possible users, which are educated users, which can co-design. It's not the same thing as having a good idea and propose this to somebody. We are used, for example, in the space industry to co-design, to look what is the best possible instrument we may have. And discuss between the users and the providers, and to do all the different connection and common analysis of what is possible. And so it's not only a user community, it's also a user community able to co-design what we are doing, and we believe that this is very important.
Sorry, I missed, you were from where? You represented?
I am from CA, but I am the work package leader in QFlag. For the end user. So, and I think this is something we want to put in place in. Yep. And anybody who wants to provide us with proposal, information to connect with those communities, we are ready to help.
Okay, so the point is QFlag is already working actively to connect to the large-scale facilities, and the Grenoble conference will be one way to target it. I guess, yeah.
Stefan, we just keep another comment, even if we are a little bit late, because I think that missing topics inside the flagship is one of the most relevant things, so please.
Yeah, okay. Kai Bonks, University of Birmingham, and Director of the UK National Quantum Technology Hub and Sensors Metrology. I just wonder if we are at the time where we need to connect the technologies we have to applications and essentially think not just about like what for atomic clocks, what for atomic miniature vapor cells. So what's the aim? So how do we connect the whole thing to industry, which will need to happen in the second phase? So in order to connect, we have to have an idea of the applications. To say, like inertial sensors for navigation, for instance, or something like that. So I think it needs to evolve in that direction.
This is, I think, the topic of the next slides, of the next couple of slides. So I think that we can move on, and because this is what matters at the subsequent slide.
Yeah. But anyway, to summarize, I mean, there is already now a need, and maybe man has to be more focused on finding what are the applications and how do we get that from a technology point of view.
Oops.
Okay.
Mathieu. Okay, so we listed a few on the areas that were on the previous slide. We listed a few goals mainly from the European Roadmap on Quantum Technology for the different areas here. But I guess we can add something more to these areas, or we can say something about other technologies. So, yes. Can you answer that, Mathieu? The question was, what is the connection on this slide to the previous one? I guess. Yes, to be able to write goals. We can add here. That's okay with you, Mathieu?
Adding goals here is yeah, that's the aim.
Okay.
Right. So the miniature atomic vapor cells, definitely biomedical applications, absolutely should be there. And another thing, the quantum enhancement of gravitational wave detectors, this is what I alluded in my previous speech. It also is linked to the atomic vapor cells, actually.
Thanks. I don't think I need to repeat.
Yes.
Paolo Bianco again. I think one of the goals is to keep ahead of the existing competition. I think this is one of the fields where in Europe we are relatively strong, probably leading. I say probably because we might not be aware of hidden and secreted development, but so far it looks like we're leading, and we should be very, very careful on keeping ahead of the competition. It must be one of the goals.
Okay, so we have a general goal for Europe to keep ahead of the competition. So I guess we will eventually have more time for coffee if this is...
Phil Marsden, Unitive Design and SME. I would like to comment, I think, on the standards and follow up on what Kai was saying a little bit. We've seen in the UK, my company had a little bit of involvement in the program there. Engagement with the end users is absolutely critical. This is what you need to achieve in those first 3 years, and it's going to be difficult. SMEs like mine, even larger companies, will not want to take a lot of risk. I think we heard that in the previous session as well. So how do you de-risk that? I think by working with other academic groups, we've seen this in the UK, who already have a foothold in those areas. This is not quantum computing, this is metrology. People already understand magnetic sensing, gravitational sensing, accelerometers. There are people studying this, there are people working with these large companies. And I think it's an opportunity to not be introverted, but a little bit extroverted in those first 3 years.
Okay, so important is for the companies that they establish a contact with the end users, because this is a process which takes time for the companies, and that has to be started now.
We've got, okay, yes, you, and then Hugh.
Okay. Yeah. So, Martijn Hek, Aarhus University. To follow up on the previous question on to stay ahead of the competition, it would be nice to have very accessible data on, first of all, where is the competition, where's the competition going? I mean, there are roadmaps. If you develop something here, then by the time you actually have it, the competition is already a few years ahead. And maybe, I know this is not a one-on-one discussion, but on a personal level, it's always very hard to get those quantified data, especially from a defense industry. I mean, it could be that we do interesting stuff for defense, but typically they don't give the target metric. So if you're willing to do something like that, that would be very useful for the development of technology.
Okay, so if I try to summarize that, one point is, how do we know where the competition is? I mean, that was sort of one. I mean, I guess all research groups always are asking in some sense or keeping track of that. But I guess more specifically your point was, when we come to defense industry, they must tell something. Is that correctly understood? Okay, yeah, we'll catch that.
Yeah, what I believe could be put on the list of applications is environmental sensing beyond gravimetry. So I'm talking about gas sensing or isotope analysis.
Sorry, I'm really sorry I didn't get it.
So we were talking about...
Oh, it works. Yeah.
We were talking about goals, and I think what one can put on the topic with respect to applications is environmental sensing beyond gravimetry, so gas sensing or isotope analysis.
Okay, yes, okay, yes. Yes.
And optomechanics.
Okay.
Okay, so environmental,
I'm not sure it is, okay, maybe not really based on this, but other sensor, gas sensing, yes. Okay.
Markus Aspelmeier from the University of Vienna. So this goes along the lines that what has been said already. But one could, as a more general goal for the next maybe even just 12 months or 18 months, have identified use cases for the different branches of technology or for different applications. So, for example, medical, environmental, and so on. These are just the broader umbrellas, but really identify specific use cases in medical, environmental, defense, and so on, by talking to all industrial partners, by engaging more communication, and basically using here our technology that we have, exactly following what we want to do, namely making use of our advancement. Other example would be the space sector, right, where also we have, so this follows along the lines what has been proposed to engage with other more large-scale or different large-scale undertakings of different fields. So engage and identify by month 12, 20 really strong use cases, including business models and so on.
Yeah, so can I ask a question? I mean, in the European Quantum Technology Roadmap, I mean, there was of course listed a number of use cases. Do you feel that there should be more use cases, or they should be more specific?
Well, these are not two separate questions. I think there should be more specific use cases. Now, we have here a couple of them are listed right now, so but they should be definitely more specific. So accelerometers is very generic, as is medical applications.
Yeah, thanks.
Ferry Kinberger from Keysight Technologies. If I read the technology and the goals here, they are pretty similar to what I see as a chair for the Fed Open and the Fed Proactive. So what I miss here a bit is the link of the goals to business relevance, not to SMEs, because there are several SMEs involved, but I see the major link to big industry, and I think this should be implemented. I don't have an answer for this right now, but I think you need to work on this such that big industry, not only SMEs, are also jumping on these particularly small topics. It's a challenge, but it is possible.
So the upcoming strategic research agenda should really also be clear on what are the business cases in the things we are discussing. That's your point.
This guy? Okay, yes, we are running out of time. So just a comment, and then anyway, we will have the next slides with 16 years perspective. So essentially, we continue this discussion.
So maybe this is too obvious, but one clear goal is the overlap and the sensing for other pillars, for quantum computation, for communications. Very obvious case is single photon detectors, which you can find in the market these days, but they are, I mean, they can still be improved. Right? I mean, so we should think about that. And the other clear goal is interaction with the other flagships. For example, brain-machine interfaces, which is a very obvious case of medical applications, and it's useful for many things like defense or many other things. Thank you.
Yeah, so the point was interaction within the flagship and interaction with other flagships.
So, yes, what I would like to do is, let's move to the next slide, and then we have comments by people, because anyway the next slide will be the perspective in 6-10 years. So we are anyway speaking about future perspective, so I think that most of the comments are not really strictly connected to the 3-year perspective. So I think we can move to the next slide.
So some things are the same, but what has been changing is that the I, or the red part, are sort of goals at industry level, where S is science. So some of the science goals that were on the last slides are now industry goals in this perspective. So there are some things which are the same, and there are some new things on this list.
So we got the first comment.
My name is Roger Verberg from TNO in the Netherlands. I would like to introduce the word impact in this pillar, and I think it's also what Marcus and the colleague from Birmingham is hinting on. If you compare this, and the competition is also quantum computing and quantum internet, where they make big promises of potential impact on European society or European economy, where here we have a list of great technologies and interesting applications, but what's the big change for European society? the other pillars may be more risky than this one, but if a policymaker has to make a decision for a quantum computer with all potential impact or squeezed states, I'm afraid I know what they will choose.
Okay, so actually, I guess the quantum sensing pillar was the best funded, or the second best funded in this first call. But a key issue is to identify the impact things, and that's also a key things. I mean, for the community, but for the strategic research, and again, then yes, in general. I'm sorry that I'm summarizing all, but I think anyway.
I think what should be put on the list of the goals is miniaturized atom clocks and space clocks. Also ambitious within 6 to 10 years, but it should be on the list if it's not already.
Yes. So on the goals, military atom clocks, miniature clocks.
Miniaturization and space clocks. And space clocks. Space quantum clocks.
Okay, space quantum clocks.
Okay, then this guy. Okay.
Paulo Bianco, I would like to reiterate on what Roger said before. Probably something that we will need in 6 years' time, 6 to 10 years' time, will be also telling the potential users what is possible to do and what's the future in this field. Because otherwise it is going to be, it's not going to be looking very, very attractive, and there's still a lot of lack of information in potential users of what are the capabilities of quantum sensors.
So your point is in the 6-year goals. Do you mean we have to formalize those things now? Is that your point? Or at that time we must be much better at it?
At that time we must be much better at that, and we must involve the user community.
Yeah, I think it's a little also, I mean, just adding that sort of in the line with what Marcus Aspelmeyer said. So it's for enforcing that statement.
Yes, Stefan Kück, PDB. So coming back to the point with space quantum clocks, I think clocks is time, and time is something which, of course, also the National Metrology Institutes are very much involved in. Just would like to point this out. And the other point is it really clocks or frequency reference frequency standards and so on? We have to be, I think, also precise in the wording here, and to get it onto the right track. This is just a comment on my side.
Okay, so we shouldn't only talk about clocks, but also about frequency standards sometimes too.
Sorry, so one point, and the second point, my actual first point was we have to think about the National Metrology Institutes if we talk about clocks, because they are working on clocks and optical clocks. So this is something which we should keep in mind here if we talk about clocks and time, because this is really something with the national, and that is very much involved in a lot of national laws, that the time is a significant part of it.
So was your point, okay, your point was it important to emphasize that it's national metrology institutes, or was it about timekeeping?
So actually both, because I mean time and time is very much, how to say, already internationalized, and you have standard times and so on, and a lot of national metrology institutes are working on the quantum clocks. So I just would like to emphasize this. This is an important part here, and also we should also think about to make this reference standards also available to the market. I think there is a market for clocks. So there's rubidium clocks, there are cesium clocks, but the next stage would be go into atomic clocks, which are available to the market, not only sitting on the table in some institutes or in the National Metrology Institutes, but really available to the market. So some really desktop optical clocks.
Yeah. Okay, thanks.
Okay, you'll go to the...
Yeah, I would even start with a comment, Rainer Erdmann from PicoQuant. Having these standards as soon as possible available is also very important for companies, because you have to design your instruments. If you want to sell it, it has to be really in confirmation with the standards. And that would be really a pitfall if the standard's coming later and you have to make a redesign, because time is money at the moment. And we had the discussion also in the previous session in the other room, that especially governmental security will be the first application because they have money. But they will definitely ask for standards to be sure that what they are buying is secure. But my comment went in another direction. When I raised my hand, in 6 to 10 years, I'm pretty convinced that we have in this field of cellular and subcellular NMR already technology available, which has shown proof of concept, which is used in basic research. I'm coming from the optical field, but our technology is more and more used now also in the quantum field. And I would already raise attention at the moment to consider hybrid instruments, where we benefit from the nanoscale optical resolution, which is now a standard, and have always in the back of your mind that you design your NMR instruments, that you can benefit from both, that you get structure information, functional information with one instrument.
Okay, so something that will come is cellular and subcellular NMR. I think your comment on standardization, we will actually get back to that a little bit later.
So I think we can move to challenges. It's something that we have already started a discussion, because most of the comments were towards the challenges that is facing this field.
Yeah, so this slide is what will stop us. I think we can also think a little bit general. I mean, we can think about technical things, but we could also think about organizational things that stops us. It's also a little about I think maybe if you could say something, Mathieu, about the comments here at the spin quantum sensors.
So I guess here what we're trying, since there is kind of already an agreement on the goals and where we go here in this pillar, is to try and go the next step and identify what are the important challenges associated with these goals, and in particular try and set up a key parameter so that we can measure how close we are getting to the goals that we are setting up.
So one point here is that, you were done, or? Yeah, so one point here is that we have a rather, I mean, sort of a rather high-level discussions, but once you sort of get into actually doing something, I mean, then you get into what are the coherence times, what are the numbers, and so on that you see. So it will be much more specific at some point, and especially from an industry perspective. So this is sort of another thing, but I think what we solicit at this time, I mean, do we have a general problems when we think about achieving the goals in this pillar? Do we have specific science cases which we think are really important to solve? We will get into enabling technologies and supporting technologies in a later slide, but anyway, we can mention something now as well.
I think to have a successful input to the market, we should also think about integration. I think I'm missing the whole part of integration, so it makes no sense to have a bulky laboratory set up somewhere. So this is, I think, one key word in the original document, and this is, I don't see it here, so we have to keep that in mind.
Okay, so it's integration. I mean, are you then talking about putting together the device or integrating different stakeholders, both? About the device. Yeah, thanks.
Stakeholders together is also.
Thanks.
So I'm not sure if you got my second comment right. So I would like to have it listed because integration goes in the same direction. So I mentioned hybrid instrumentation, which is also a form of integration to combining organic single quantum states called molecules, what Professor Ernst also raised. So having optical and magnetic and maybe other methods integrated into one method. Because we learn from many applications that the amount of information from a single method is not enough, that the next step will be using information from different applications, and then we come close also to the quantum computers, because to really use this huge amount of information, we are very close using quantum computers. So if you could make a note about hybrid instrumentation, combining different methods, dealing with big data, that would be nice.
Okay, so I'm summarizing what you say. I mean, one key thing in getting further in technology and in science is that we have to use different fields, not least in medicine, so we have to use, well, that's the hybrid part.
I think in this community, the pillars are the 4 pillars of a quantum flagship. And while this could be, but really different technologies, measurement engineering technologies. So maybe I'm not sure if the wording is correct, but maybe we can do that afterwards in a coffee break.
Okay, thanks.
Yes, and then him.
Yeah, it's me? Okay.
Yes.
So it's also the networking between the different sensors that might be of interest in the future. So if you think about geodesy or something like that, yeah.
And when you say different centers, what do you say?
So it's different sensors. So
sensors.
Sensors, different locations, but also different type of sensors operating together, like hybrid. This was already addressed here, but yeah, it's also networking between.
Okay. Paolo Bianco, I think one of the challenges will be coming with it's not very popular, but for us it is important, with a consistent TRL definition at the end of the work. Whatever has been committed at the beginning of the project, this must be delivered, and the technology readiness level must be consistent and ascertained.
Okay, so I translate that into that the strategic research agenda also should address technology readiness levels.
Tino Fuchs from RobotWash Cooperation. We see a challenge coming from legislation, from export control. So we want to develop a gyroscope for autonomous driving based on quantum sensors. And if you look at the specifications that we go for, you will see it will be good enough to guide a missile precise enough to hit a target. So actually we looked at the papers of the legislation, and we would, when we succeed, get in conflict with this. And this could, in the end, maybe in 5 to 10 years, be, if this legislation is not changed, be difficult to sell these products in the world market. So this is something this has to be acknowledged, and maybe some action has to be done by politics, because it's not only for the quantum sensors, also advanced MEMS sensors that are needed for the application run into this problem.
Sorry, could you say what was the problem with the legislation in this case?
So there are, in the legislation, there are numbers for the bias instability, for the angular random walk of the sensors, and there are numbers, and the targets that we have in the project, they are, so to say, in the scope of these numbers, so meaning it's military grade. And from that moment on, all these restrictions from export control are active, and you are, so to say, not anymore free to operate.
Okay. So export control is one of the issues.
Is the issue, that should be kept in mind. If there nothing changes, we will run into a problem where we want to sell the products, and even if we want to cooperate with international partners.
So what is your specific suggestion when it comes to export control? Maybe you already said it, but I guess I didn't get it.
The point is, it's a challenge, yeah, that could
okay, thanks.
give
Yes.
a risk
So,
that it
thanks.
cannot bring the
Export control technology. This guy and then this guy. Okay.
Hello, Nadav Katz from the Hebrew University in Israel. One of the challenges I've encountered with quantum sensing is that the supporting infrastructures are too expensive in the sense that the electronics and the lasers and all the packaging is just too expensive for many of the applications. So people say, sure, you can build something which is 10 times better than the classical, but it'll cost 100 times more. So we don't want it. That's a lot of, I'm getting that a lot from industry. So I'm not an economist of scale, and I don't know how to answer that, but it's something that we've encountered as scientists when we come to sell our quantum sensor. People say it's just too expensive and too complicated. We prefer to go classical. So I think maybe other people, from the nods I see, people have seen that. I don't know how to solve it, but it's a challenge.
Okay. Cost is a challenge, cost of the components.
Yeah.
Or parts.
So my name is Schmidt from Czech Metrology Institute, Nation Metrology Laboratory, and it's probably important for my comments. I've heard a lot about sensing, but this is sensing and metrology. Speaking about metrology, probably it's worth to know that one of the challenges, maybe future implementation of these quantum standards into, primary absolute realization of a unit, SI units in the world, and make it equivalent. So probably something like that could be known there as well. Because sensor is different than metrology equipment than the standard.
Okay, there is work to realization of standard for the sensor.
No definition, but realization.
Realization.
Not definition. Okay. No definition, please. Or realization. I will come later. Thanks. Yeah.
Yeah, maybe should I?
Yes.
So as a follow-up on the TRL levels, when the technology is about at the TRL level from 4, then maybe the scientist should think about putting this into a standard. And the problem or the challenge in this context is that in the quantum technology standards is not yet much known to the scientist how to, because it's a new field, and the standardizators, they don't have experts or committees set up on this specific field. So I think this is a challenge which needs to be thought about at this stage, how to set up slowly a process so that in this new field of science, both parties are putting their actions into place to think how they can bring then these technologies to the industry or to the small and medium enterprises, and that a communication is guaranteed between the devices so that the user can use it and the market can absorb it. Thank you.
So at TRL 4 and above, there is a clear need for standards, and there is a challenge in terms of what or how should standards be defined in the quantum technology area, which we haven't looked at.
Okay, we will have these last comments and then we will move to the technology section.
Okay, just to add to, not just think about cost and but also size, weight, and power. I think that's a major challenge. If you want to translate it to industry, you also have to think not just about the sensitivity, but what's the size, weight, power, and cost of the instrument, and that needs to be addressed in the flagship if it wants to attach to technology.
Okay, both size and cost.
Yeah, size, weight, and power. Power is very important as well.
Okay, power consumption, you mean?
Yes.
Yeah. That's a cost. Okay, so let's move to the technologies. Okay,
Okay, so these are cross-cutting activities, software theory, engineering control, basic science. What is important for quantum sensing? What do we need? Maybe we can could you show also, just go to the next slide, Mathieu.
Yeah.
So you see that we have standardization certifications and fabrication facility. So we will get to those points, but we'll start on the first slide.
Okay, so in terms of engineering, I think for all atomic quantum sensors, you need very precise laser systems, which are like small, robust, self-locking, and like good to 1 part in a billion.
Okay, thanks.
And low cost.
It's a very specific comment, but I'm trying to reach out to companies in Europe who would be interested in the following. There is a technology which is called alkyne coating of glass cells. And this technology actually undermines the production of ultra-sensitive room temperature magnetometers. There is one guy on this entire planet who happens to be in Russia, who knows best how to do it. And, well, Chinese are trying to cope. This guy works, he worked for me, and then he worked for a geodesics company in the US. So if there is any company or any other enterprise who would be interested in collaborating on developing such coatings, and the general recipe is known, it's a matter of kind of training a person. Please talk to me.
Okay, so there is the general problem that we want to have the technologies in Europe, and one example is alkyne coating of cells.
This guy and then this guy. Okay, yes, okay, go on.
Okay, well, I find some of these statements incredibly narrow, because even there it says engineering diamond. Now, for example, when I mentioned quantum plasmonics, I would say materials preparation is something important, and in that case it would be nanoparticles, or it would be very tailored nanoparticles, but I would not restrict it to a particular element. And I find that everybody comes up with a very, very narrow example of something, of coating with a particular element, but we need in this long-range planning, and we are talking about 10 years, the goals, when we write down diamond, well, could I come up with a proposal of preparing, I mean, that is what we are already doing, gold-coated iron nanoparticles. So we have magnetic and plasmonic properties there. It wouldn't fit into any of these statements. So what should I do, basically? Just get out of this area here, or out of this planning. Okay.
Add these things there.
So preparation of tailored nanoparticles, for example, right?
Yeah. that would be.
Rob said we shouldn't comment. We should just sort of take in the comments from the audience. But I mean, I agree completely. I mean, we have to be general. It's good to have specific example, but.
Robert Jordens, Quartic. On the software side, I would like to see some work on data provenance, so software stacks that guarantee proper data handling, archival, that area. And on the control, also with an eye on control software, on control systems that you can trust. So you can inspect and you actually can certify yourself by inspecting them, modifying them.
So we're looking at software, we're looking at control systems. This was also up a little in the quantum computing discussion, and it's slightly different form, but it's similar.
Actually, I would like to comment on Diamond, because it was a question. So we have a quantum flagship project on Diamond for magnetometers. And this is not a question of the Diamond, but it's a question of the scalability of scalable technologies in general. Because today we have companies already in that field who produce those materials, but the volumes are rather small. So I mean, very good if we could somehow find a way how to support the upscaling for these materials, because they could be especially interesting because they could be used in combination with semiconductor technologies. And I would like to point towards US initiatives, because in the US recently they start to support silicon carbide. So there is quite a large initiative on silicon carbide as an engineering material working with solid-state qubits, which can be upscaled and also interface to the electronics, to the classical electronics. So in that sense, I would think that it would be very good if you would find a way how to support upscaling of materials and engineering and kind of the quantum coherent materials which you can use for those applications, such as magnetometry, for example.
Alexei Feofanov, EPFL. So I have a comment about diamond and in general materials. In all the slides, the diamond or NV centers or color centers were mentioned. So basically diamond is very important for short-term demonstrators and application of sensors. And indeed there is a problem with materials in Europe because there is more or less one supplier for CVD pure diamond, so it should be supported and upscale. But I disagree with what's written on the slide, because it's implicitly mentioned that you should grow clean material and then implant NV centers. And other approaches are discarded by this definition because you can dope while you grow. You can dope with different materials, you can try to structure before continue your CVD growth, and we should allow you to fabricate more complicated diamond structures. And for example, if you combine these approaches with imaginary diamond insulator, so single crystal diamond insulator, this allows you to connect NV centers or other color centers to diamond photonics, and which can again allow new devices also for computing. So you can get cross-cutting to the computing with NV centers. Thank you.
Yeah, again on this discussion on the specificity of diamond, I was actually going to say the same thing that was said just before about the fact that surely the diamond system is a prominent one at the moment, but it would be probably a good idea to sort of enlarge and refer to wide bandgap semiconductors and defects in wide bandgap semiconductors, just to avoid to be too narrow. Personally, I'm working on diamond, but I totally agree with what was suggested before. Maybe we should refer to a broader class of materials, just to avoid to look too specific.
So also concerning engineering, there's also the ultra-precision manufacturing of devices. the ultra-precision manufacturing of devices, so like say traps for multi-ion traps and so on and so on. This is very important, and this is a demanding technology, so only a few people can do that. I think this is very important to have it on the scope that we need it to go to the market, to do integration and so on and so on. It's ultra-precision manufacturing. I just would like to avoid that we have specific items here, because it's a general remark. So it's like it was like the comment before, or several comments before. It's really in general something we have to take care of. And there are some use cases we could probably give as example, but main point is the ultra-precision engineering and manufacturing.
I think this is the last comment regarding this part, and then we will go to the bonus question.
Roger Verberg from TNO again. I wonder, in this list of topics, I recognize a few of which I think I know people that can cover these topics. So my question is, are these the topics that have to be addressed in Europe for the first time? Or do we have to improve an accessibility and spread the word at what colleagues you can find these technologies?
So I spoke a little to Rob. I think the ambition is that sort of put what we have here on the web, so it's available actually for people to write in suggestions for a period of time. Obviously here, I mean, we are leaning sort of just in one direction, so it's clear that, but it's also not, maybe it's, yeah. So there will be time. There will be time for more input, and of course we are not only talking about this.
So let us move to both the bonus questions.
I forgot that.
Oh. Oh, yeah. Oh, no. Still this one. Okay. I think that we had already had several comments regarding standardization and certification. So
yeah, we'll.
Excuse me. Excuse me. May I add something about the foundry? Because you mentioned optomechanical sensors beforehand, and in a FAT proactive project which addresses hybrid optomechanical technologies, what we try to show that it's possible to fabricate useful optomechanical systems using current day silicon photonics foundry. So you can use approach not making new dedicated foundry for something. You can try to adopt your designs for the foundry which exists and was developed in a parallel community. Thanks.
And in addition, you can use existing, I mean, just commenting on your text, you can use existing foundries and modify it for the needs.
I think we'll go to bonus questions. Yeah.
Go to the next one. So this is just a collection on various things. I mean, I guess we should end in 3 minutes or something like that. But we'll take, if anyone feels that, yeah, there is really something we should say about some of these questions, please.
Well, maybe in follow-up on the previous comment, when we talk about the weakness of the flagship, it's obviously that it's a quantum technology flagship. So people who are not affiliated with quantum won't be here. As this speaker already, or his point was already, there are a lot of skills out there, there are a lot of technologies out there, and it would be complete suicide not to make use of those technologies. So the weakness is obviously that these people are not aware of that. So then the question is how to include them. And And then another weakness might be what we sort of need to overcome is then, of course, the willingness to include them, because that basically means also, you know, share the pie with more players, which there's always an intrinsic resistance against.
Okay, so the point is to do quantum technology, you need normal technology, and they need to be in if they can to contribute, or at least one needs to talk to them in a good way and include them in the discussions.
I think one of the possible weakness is the connection between the pillars, which is maybe not yet clear in what we are seeing. And for example, we know that sensing, you can have products, for example, like parametric amplifiers or detection of a single spin coming from another, for example, from the computing, or maybe some other things. So we can use also maybe in qubits in order to improve the sensing. And those connections, probably they have to be organized in some way, and this is not yet seen. Maybe it's discussed in the other room, but we have probably to think more about this, maybe also proposing what are the results of the different projects to a brainstorming, or maybe strengthening calls for specific application of a component, for example, developed in one of the pillars, saying that we reached some milestone and maybe this is useful for another pillar. But I think we have to invent something for those synergies.
Yeah, the project both needs to look at the other projects for synergies, and they also need to look around on, for example, in the technology area.
Well, I may just add on what was said on this side. I think it's pretty obvious that this flagship was somewhat grown out of a group of quantum optics people, and there is this other community of quantum materials. So, for example, it can be done indirectly. For example, for one of the unsuccessful proposals, I contacted our friends in Aarhus. There is in Aarhus a big center for Dirac materials. This is certainly a big resource of things which can be done within the flagship. So I would ask that people who are aware of this in this community, they should try to pull in some of these other colleagues.
Okay, so one large area which is underrepresented is quantum materials. I mean, if we look in solid state, and it's important to bring that in.
There is still one comment, and it will be the last one, and then we will end the section.
Oh, great. Oksana Mishina, TU Braunschweig. Very brief one. I really like the second question. What is the added value of the quantum flagship? But I would like to ask your comment about it, because the flagship started yesterday. Before, it was called the launch of the flagship. And I think it's very important to understand that, because the launch showed us a lot of problematics and gave us a lot of space to dream. And this has its own added value, but it's not yet the added value of the flagship. Does not yet exist, I think, right? So what are we targeting here? Is it the added value of what we have been doing till today? Or is it a future perspective of the added value?
Future perspective.
Future perspective. Okay, so what would be the added value of the flagship? Well, I have to think about it.
Okay, I think we'll, thanks a lot for the comments, and again, I think please, if you had input, talk to Mathieu and give your name, and also you can check that we wrote something that actually was what you were planning to say. So I guess it's time for coffee. Thanks. Okay.
And when you come back at midday, so we'll come back at 12 o'clock, and tell your friends we'll all meet in here. It'll be just one plenum session. So see you shortly.